Hello Math 10a. Here is a worked example video for section 3.3 on differentiation rules. So far we've been able to take derivatives with the limit definition, but now we can leave the limit definition behind. And unless we have a question specifically asking us to use that, we never have to use it again, which is wonderful because it's a very big, clunky definition. So instead, we're going to use the product rule and the quotient rule. Here I'm going to set up the product rule, give these two bits of the my function here names. So this is f of t equals t cubed minus 2t. I'll call that g of t. And this bit here, t to the negative 4 plus t to the negative 2, I'll call h of t. And we should remember the product rule says that if f of t equals g of t times h of t, then f prime of t equals g of t times h prime of t plus g prime of t times h of t. So two terms, you take the derivative of a different one each time is one way to think about it. And so what we need to do, we already have g of t and h of t, so to plug into the formula we just need to find g prime of t and h prime of t. So g prime of t, that's going to be the derivative of t cubed minus 2t. And for that we can just use the power rule. So derivative of t cubed is 3t squared, and derivative of minus 2t is just minus 2. And as we know, the derivative of a sum is the sum of the derivatives. So we can just take those derivatives separately and add them together, and we're all set. Same for h prime of t, we just use the power rule, so we get minus 4t to the minus 5 minus 2t to the minus 3. And now we are all set to plug into our formula, and we'll get that f prime of t equals, so g of t, t cubed minus 2t times h prime of t. And I'll bring this negative sign out front and write 4t to the minus 5 minus 2t to the minus 3. And now g prime of t, that's 3t squared minus 2 times h of t, which is t to the minus 4 plus t to the minus 2. Okay, and now we're done with the calculus part of the problem, and it's just some algebra to simplify. So I'll go through this. We FOIL this, we get 4t to the minus 2. Remember the exponents add when you multiply them together, so negative 5 plus 3 is negative 2. Here, t times negative 2t to the minus 3, that's going to be just negative 2. The t's cancel. That's nice. Here we get a negative 8t to the negative 4, and here we get a oh, okay. I had done this problem before and noticed something was different. So here is where I messed up. I factored out, well, I attempted to factor out this negative sign, but forgot to change the negative sign here to a positive sign. So make sure you watch your negative signs. That's always a big source of trouble. So okay, that's a positive sign. And now we get something nice happening. We have negative 2t times positive 2t to the negative cubed. So this is, sorry I'm not writing legibly right now. That's a negative 4. And we multiply these together, we get minus 4t to the negative 2. And that's nice because it cancels with this right here. So those just go away. All right, now we'll just do the same thing over here. We get 3t to the negative 2. Try to write legibly. This is just going to be plus 3. Here we get a minus 2t to the negative 4 and a minus 2t to the negative 2. And now we combine like terms. We have a minus 2 and a plus 3, or should that be a minus 2? that should be, in fact, a plus 2. And then we distribute a negative sign to it, so it is a minus 2. So again, with the negative signs, you should always go back and make sure you're not missing those. So that is a plus 1 because it's a negative 2. Here we have positive 8t to the negative 4 because we distribute this negative sign, minus 2t to the negative 4, so that is plus 6t to the negative 4. And then we have 3t to the negative 2 minus 2t to the negative 2, that is minus t to the negative 2. And this is now a nice, simplified final answer. Okay, so hopefully my messing up the negative signs didn't throw you too much. I think I corrected everything by the end. But you should go through and check, make sure that you agree with all of my negative sign placements. And now we'll come down here to a problem using the quotient rule. So we will have, I'll do a similar thing, I'll give all the functions names. So we'll say f of x equals square root of x, and I'll say h of x equals 2 plus x. And what does the quotient rule say? The quotient rule says if g equals f of x divided by h of x, and h of x isn't 0, then g prime of x is, I remember, bottom d top minus top d bottom over bottom squared. So what does that mean? That's the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom function squared. So this is a bit of a tricky formula, but it's one you've got to remember, because taking the derivative of a quotient is just a super important thing to be able to do. And now, just like before, we just need to find the derivatives of f and h and plug right into the formula. So f prime of x, well, f of x is just x to the 1/2, so this is yet another power rule. That's going to be one of our main rules, especially for now. And h of x, this one, is very nice because it's just 2 plus x. The 2, derivative of that is 0. X, derivative of that is 1. So h prime of x equals 1. And now we can plug in to our formula here for g prime of x. So g prime of x equals h of x, that is 2 plus x, times f prime of x, which is 1/2 x to the negative 1/2, minus f of x, which is square root of x, times h prime of x. Well, that's just 1, so times 1, that doesn't do anything. And divide this whole thing by 2 plus x squared. Okay, and now we have this whole thing with square roots, different powers of x. I think it'll be a little nicer if I write this as just x to the 1/2. And I think the first thing we'll do, it may be unclear how to simplify this at first. The first thing I'll do is distribute this term out. So we get g prime of x equals the 2 and the 1/2 will cancel, which is somewhat nice. And that's just x to the minus 1/2. Then we get x times x to the minus 1/2. So that is plus 1/2, and that's x to the 1/2. Right, and then minus x to the 1/2. And divide that whole thing by 2 plus x quantity squared. And now, okay, we can combine two of these terms together up here to get just 1/2 x to the 1/2. And we still have this slightly unseemly negative exponent in the top. I'm not sure how much I like that. I'm just double checking my work here, but I think it all looks good. So that would be plus, or rather minus 1/2 times x to the 1/2. And this is x to the negative 1/2, again, watching the negative signs, over 2 plus x squared. And one thing we can do, I think, to make this simpler is just to factor an x to the negative 1/2 out of everything on the numerator. And so that would leave us with x to the 1/2 times 1 plus, or rather minus. What happens if we factor an x to the negative 1/2 out of this? Well, that's the same as multiplying it by x to the positive 1/2. So that's just 1/2 x, actually. And this is over 2 plus x squared. Maybe it'd be even nicer to make this into a 1, make this into a 2, and factor out the 1/2 as well. And then we really don't have any compound fractions. We just get a 2 minus x over 2 square root of x, 2 plus x squared. And that is our final answer. So some work on the simplifying, but the actual calculus here was not bad at all. The actual calculus kind of ended right here. So calculus, and then below here is all just algebra. And the algebra can be tricky, and you've got to know the algebra, you've got to be strong on the algebra, but hopefully that's not anything that's super new, a review at most. The new stuff is just taking a few derivatives that are much simpler than this one and plugging them in to a formula that you remember. So I hope that was a helpful video. I hope you try it on your own and get the right answer, and I will see you next time.